Good day, everyone. Today we are talking about section 9.5, scatter plots and best fitting lines. So our learning targets for today, I can determine if a scatter plot has a positive, negative, or no correlation. I can construct and interpret a scatter plot. I can draw a line of best fit. I can calculate the line of best fit by hand or using a calculator. So we start with what is a scatter plot? Basically, it's a display of bivariate data. Which we know the bi means two, so bivariate is a fancy way of saying two variables. So what happens is we're going to have, when you collect data, there are multiple variables, and we're going to see, is there a correlation or a relationship between the variables? And one thing to note, that correlation does not mean causation. And we'll get into a little bit of that in class, but there are three basic types of correlation. If the points are generally going in an upward trend, we say there's a positive correlation. As x is getting bigger, y is getting bigger. If x is getting bigger and y is getting smaller, we say there's a negative correlation. Correlation is kind of like slope, because when we draw our best fitting line, we're going to draw a line that kind of represents these points, and it's saying the correlation is like the slope of the line. And if the points are all over the place that you can't really draw a line to represent it, we say that there is no correlation. All right, when we go and do the line of best fit, there are two ways to do it, by hand and on the calculator. I'm going to go over both ways, and then on the test, you'll be allowed to do it either way. Most of you are going to choose the calculator way because you're going to find it's easier once you get a hang of it. All right, so line of best fit by hand. So what you're going to do is you're going to draw a scatter plot of the data. Here we have our scatter plots are given to us. And then when you sketch the line of best fit, you need to have as many points above the line as you do below it. That's where it's 50-50. You need to have as many above as you do below. And so we're going to draw, let me switch to my line tool here. All right, so we're going to draw a line that best represents these points with as many points above as you do below. You want to go through as many points as possible as well. So something like that, if I look at it, I've got 1, 2 points clearly above, 1, 2 points clearly below, and I go through a bunch of those points. So that would be my quote best fitting line. And we can see that this line has a negative slope, so we would say that this scatter plot has a negative correlation. I'd like you to try the next one on your own. All right, now when we do this, I'm just a little off here where I want to be. Just give me 1 sec here to fix this. When we do this, what we're going to do is we're going to identify 2 points in which our graph goes through, and then we're going to estimate the coordinates. So I'm going to say that this looks like it's about 620H, and this other one here at 2 looks like it's about 212. If you have the data points that you made your own scatter plot, you're going to use those data points. Step 3, choose 2 data points on the line. We just did that. Write the equation of the line through those points. Now, you may recall all the way back in chapter 2, we talked about writing the equation of a line through 2 points. And so the first thing we need to do is find the slope between the 2 points. Again, y2 minus y1 over x2 minus x1. So we're going to go 28 minus 12 over 6 minus 2. We get 16 over 4, which equals 4. For luck, the 2 points that we picked are our slope works out to be an integer. Again, this could get messy if we start getting some weird fractions when we do our slope. And that's the biggest reason people choose not to do this by hand and choose to use the calculator. Once you have the slope, we're going to use the point slope formula, which some of you may remember is y minus y1 equals m times x minus x1. So you're going to pick one of the points. I'm just going to pick 212. So I'm going to go y minus the y value equals our slope times x minus our x value. Distribute. Add the 12 over so that y is by itself. And you get y equals 4x plus 4. So that is the equation of that line that we drew. And if you look, I mean, this is pretty close to crossing down here at 4. And our slope appears to be about 4 when we look at that line. Now, again, this can get really messy if your slope doesn't work out to be an integer. So most people choose not to do it by hand. As I talk about this, a couple things to make sure you have. Your diagnostics need to be on. You received a calculator sheet in class that is going to talk about some of this stuff too. Again, we will go through this in class a lot more, but make sure that you have your diagnostics on. So go to mode and then go down to where it says stat diagnostics. Make sure you have it on. And if you have the stat wizards option, have that on as well. That is where some of these things are going to come from, that if you don't have these turned on, you're just not going to see what I see and what I'm talking about. All right, so we're going to do part of this by hand, and then we're going to talk about some of the calculator stuff. So the table below shows the number of people, Y, who attended each of the first 7 home football games, X, this season. So what we need to do first is we need to plot these points. So please pause the video and plot those points. All right, so once you plotted the points, it says describe the correlation. I would say these are generally going up, so it has a positive correlation. Find the equation of the best fitting line and draw it on your scatter plot. This is where you're going to look at that half sheet on that I handed out in class, and you're going to enter your X values into list 1 and your Y values into list 2. So again, your L1 is going to be 1, 2, 3, 4, 5, 6, 7, and then L2 is going to be 722, 763, your Y values. Once you have those, you're going to press the stat button on your calculator, and then you're going to go arrow over to calculate and select option 4, linear regression AX plus B, and then it's going to pop up and what it shows on the screen where it's going to say X list is L1, Y list is L2. If you have an 83, yours is slightly different. It's going to say linear regression on your screen and just have a blinking cursor. You'd have to hit second 1 for L1, a comma, and then second 2 for list 2. Hit enter and it will calculate. And it will say something like, on the top it'll say AX plus B, A equals B equals. And in this case it will say that A equals 27 and B is 699.43, blah, 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 blah. Again, we're going to round it. So when we do this, write the equation of the best fitting line and draw it on your scatter plot. Our answer is a line. It's the slope of the line. So A is our slope plus 699.43 is our y-intercept. Now we're going to use this equation to find our actual best fitting line and draw that. And so we know our y-intercept is 699.43, so it's just under 700. Our slope is 27, which means it's going to go up just over, because if we look at one box represents 50, so it's going to go just over half a box per. So in other words, 2 boxes over for 1 box up. So it's going to look something like that line that we just drew on there. And again, we'll talk about doing this with the calculator to get a little bit more precise even when we're drawing it. But again, we're doing by hand. There's a margin of error when doing this. You will notice on your calculator screen that there is also something that says r and r squared. This is also part of doing scatter plots as we have these values. So let's start with the r value. R is what's called the correlation coefficient. And what it is, it tells you how strong the correlation is. And again, correlation means relationship. So it's saying how strong is the relationship. So R will be a number between -1 and 1. -1 is a very strong negative correlation, and 1 is a very strong positive correlation. And again, if R is 0, there would be no correlation. So it tells you how strong the correlation is. If it's negative, if the R value is negative, that means there's a negative correlation. And if it's positive, the closer to 1, the better, the stronger the correlation is. R squared. This is getting into really the stats part of it, but we're just going to talk about what R squared is because you see it on your calculator. It is the how well the linear model, so in other words, the line that we drew, how well the linear model fits the data. It's also the percent of variation explained by the model. R squared is always going to be a positive number, and the closer to 1, the better. If we could get 100%, that would be ideal, but that's not very realistic to get 100% of the variation explained. So again, R squared, the bigger the number, the better. We won't talk much about it, but I just wanted to introduce because you are going to see it on your calculator screen when you do it. So it says find the R value. So you'll see right below where it said A and B, there was R. So it says R equals. And again, we are going to do this to 3 decimal places. When you get into some of the statistical stuff, and you'll see this again in Algebra 2, we use 3 digits. A little bit more accuracy with 3 digits. Since it's 0.976, 1 is the max. So I would say, what does this mean? There is a very strong positive correlation. Again, 1 is as good as you can get. Anything in the 0.9s is really strong. 0.8s is pretty strong. When you get to 0.5, then you're kind of in the moderate range. When you start getting less than that, you can say there's positive correlation, but it starts getting weaker and weaker as you get closer and closer to 0. The last thing we're going to do with these is you can use your line of best fit to predict. So again, X was the attendance, so we're going to put 8 into our equation. So we're saying Y equals 27 times 8 plus 699.43. And again, we're talking about people. So we're going to round to get about 915. So about 915 people would attend the 8th game if there was one. That's what predicting is. We're going to do a bunch of these on the calculator. Oh, there's that sheet we talked about. So we're going to do a bunch of these on the calculator. So what I'd like you to do is pause the video and enter the X values into your L1 and the Y values into your L2 and then check back. All right. Now, we want to sketch the scatter plot. In order to make a scatter plot, we're going to see we're in that third set of directions down there. You need to turn your scatter plot on. To do that, we're going to hit second and then the Y equals button, and you'll say plot 1, 2, 3, blah, blah, blah. Go to plot 1 and hit enter. And then you're going to do is you're going to turn your settings on to match those of that handout. So you need to make sure A, it's on. The type needs to be the first one. Your X list needs to say L1. Again, if you need to change it, you're going to hit second and then 1. And your Y list L2. So again, second 2 to get L2. Once you are done with that, we are always going to hit zoom 9. It's called zoom stat. And it will automatically change your window to fit your scatter plot. When I ask you to sketch, all I'm asking you to do is draw your window that you see. So here's your window. I just need your, kind of show your X and Y. And it's really not the X and Y axis, but then just kind of show your points. What do the points look like on your scatter plot? Again, I'm not being super picky about this. It's like, okay, there's a point there, there's one there, another one about there, and then it kind of jumps up a little like in there, and there's about there, and then we got these three kind of look like they're in a line. Something like that. Just sketch what you see on your scatter plot. And then find the equation of the line of best fit. So you're going to go into stat, calculate, option 4, linear regression. And then all you really need to do for this is just write your answer. Y equals, and what do you get from your calculator? 40.9x plus 262.8. It's going to say find and interpret the R value. Again, this is off of your calculator screen. So you get R equals 0.993. That's a very strong positive correlation. Now, one other thing on there that it's on your sheet that I'm going to circle back to. It says to get your line of best fit on your graph. So you have this equation right here. Press Y equals and enter this equation into Y1 and then hit the graph button and your line of best fit will show up on your calculator screen. Some say it's like magic. I don't know if I necessarily believe that. But you'll get a line that looks something like that appears on your screen. When you do the equation of the line of best fit, I would like you to graph it on your screen and draw that on your sketch. Again, you are hand drawing it on a sketch, so you're kind of just showing where does the line go relative to the points. If you don't get the calculator stuff, it's okay. We will go through it again in class. I just wanted to give you some exposure. If you have any questions, make sure you come to class ready to ask them. Otherwise, have a great day, everyone.